Good afternoon. Once again, you're welcome to our channel. This is Calculation Center, and we started the journey of current electricity. And today we'll be looking at resistors in parallel. The last time we met, we saw resistors in series, and after this we'll be looking at cells also. Now today we'll be looking at resistors in parallel. Now if you look at the diagram here, this diagram is typically talking about resistors in parallel. It's talking about resistors in parallel. It talks about resistors in parallel. Now, if you look at this connection and you compare it to the resistors in series, you will notice a difference. Now, the current that is flowing through this circuit, the current flowing through each resistor is different. When the current enters from the cell here or the battery, when it enters, each resistor, because they are in parallel, they have different current values. That's the meaning of this. I1, I2, I3. They have different current values. But one thing they share in common is the voltage. They have the P potential difference at the ends of this connection is the same. You see now? So which means resistors in parallel is basically the opposite of resistors in series. So now I'll take that again for better understanding. Current that is coming from the battery enters here, but these resistors have different current values, I1, I2, I3, but they have the same voltage. So they have the same potential difference. So how do we calculate the total effective resistance? How do we calculate the total effective resistance of these resistors in parallel? So we do inverse. So it's going to be 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. So we can find the effective resistance. We can find the effective resistance by doing this. Okay, since we know that 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. So what we do is that we just take the LCM. So the LCM of this is R1, R2, R3. So this will divide this, you have R2, R3. So this will divide this, we have R1, R3. So this will divide this, we have R1, R2. Okay, and we have 1 over RT. So we can just cross multiply this so that we can have our effective resistance, which will be this times this, which is R1, R2, R3 over R2, R3 plus R1, R3 plus R1, R2. So if you are, this is basically what this one means. Okay, so what it means is that if you're trying to find the effective resistance of 3 resistors connected in parallel, this is the formula you use. Once it asks you to calculate the total resistance of the resistor, the total resistance, effective resistance of the resistors in parallel, you use this. But this I've been able to work it out for your better understanding, so that you know, once you can do this, just fix in the value. Let's say this is 2 ohms, 3 ohms, 4 ohms. So if you want to calculate 3 ohms, 4 ohms, now let's do the example so that we know. Let's say the question says you should calculate the effective resistance of, let's say like an example, effective resistance of R1, which is 2, R2, which is 3, and R3, which is 4. This is just a hypothetical example. Now, if you want to find the RT of this, all you need to do is just put the values, that's all. Just put the values like that. You do R1, R3, which is 2 times 3. You do R1 times R3, R1 times R3, whereas R2 times R2, R2 times R3, that's 3 times 4. R1 times R2, that's 2 times 3. And R1 times R2. R1 times R2, that's another 2 times 3. I hope that is okay. Let's check it. R1 times R3. R1 times R3, that's 2 times 4. Okay. Good. So basically that's what you do. So from here you say this is 6 times 4, which is 24. This is 12. This is 8. That's 20. 26. So this is 26 ohms. 24 over 26 ohms. That's all. So I just use that as an example for you to know how to use that formula. So generally the PD across the resistors is the same and is equal to the PD across the whole connection. It's the same thing. So they have the same voltage because they are resistors in parallel. They have the same voltage. But the total current that is flowing through this connection is the sum of the currents flowing through each resistor. They are not equal. They are not. That's the meaning. This is not equal to this current is not equal. What it means is that get the value of this current, get the value of this current, get the value of this current, add it together, it will give you total current. But for the voltage, they are same because the same flows through it. That explains resistors in parallel. In our next video, as I said, we'll be looking at cells now. Now we've looked at resistors in parallel, we have looked at resistors in series. In our next video, we'll now begin to look at cells also, connection of cells in series and in parallel. By that time, I'm very sure by the time you watch enough of these videos and put all these videos together, they will help you understand more as we progress in the study of current in electricity. Till then, see you.